Okay, today in our P5 topic, space for reflection, we're going to be looking at what I've just done there, and that is throwing, and we're going to be looking at projectile motion, not projectile vomiting, projectile motion. Okay, so let's have a look at our objectives for today. Okay, so here are our objectives today when looking at projectile motion. It's by the end of this lesson you should know and understand how to calculate the projectile motion of a moving object. Now I'm going to warn you again, there's quite a lot of maths involved in this and quite a bit of tricky maths as well. So anyway, I hope you enjoy this and I'll see you at the end. Okay, so what do we understand by the word projectile? Now projectile is anything that can move through air, such as a cannonball, a football, now we're going to make a couple of assumptions that we can use when talking about projectiles. Now there are two forces that can act on a projectile. Now the first one is that we'll have a horizontal force. So if we've got the Earth here, the projectile will move in a horizontal direction. Now there is only one force applied at the beginning here. So along here there is no further force being applied to that object. Now the other assumption that we need to make is that there is only one force acting on that, and that is the force of gravity. And the force of gravity will pull our object down like this. So our net movement of a projectile will be this as it moves towards the Earth. Now the reason we do this is because we make an assumption that air resistance can be ignored. So air resistance is ignored. Now we're going to have a quick look at a couple of shapes just so we get an understanding of what they are. Now the direction in which the force will, or the projectile will move, should have this alignment. Now it has an acceleration that moves downwards. Now the curved path that it takes is called the trajectory. Now the curved path that it takes can be described as being parabolic. So the direction in which it takes, the curved path, is known as a trajectory, and the shape that it has is a parabolic. Now how far the projectile will move will depend first of all on the angle of this trajectory. Now the ideal maximum is a 45-degree angle to move up, so that we get above the horizontal, so we get a maximum distance in this trajectory shape. Now if we've got a projectile motion, we'll have the motion having a trajectory like this. Now because we've got the movement here, we've got two velocities that we need to consider. We have the horizontal velocity and we have the vertical velocity. Now what that will do is that will give us our resultant velocity of the actual projectile. Now if we've got here V1, velocity 1 of the horizontal, and V2 here, we can actually work out what the resultant velocity is. Now I'm just going to so our resultant velocity of VR is equal to V1 squared plus v2 squared, and then we square root that. And that's what we looked at last time when we talked about resultant force. And that follows Pythagoras' rule. Now what we're going to do now is we're going to go through a couple of examples. Okay, now what we're going to do is we're going to have a look at the question. Now, at the end of last time, I mentioned something called SUVAT. Now, I'm just going to go through how it actually works. Now, I'm going to go through the question, okay, and pick out the information that we've got. So, we're looking for a distance. Now, if we look at the question, we've got a distance here of 45. Okay, an initial velocity. Now, a stone is kicked off, okay, a cliff, so we're assuming that the vertical velocity is 0, so we can write in 0. A final velocity, when it hits the sea, we don't know. The acceleration, now the acceleration due to gravity is equal to 10 meters per second squared. And usually you'll be given that in the exam question, but we do need to be aware that acceleration due to gravity is 10 meters per second, and then t for time is a question mark. We don't know what that is, but we do need to know, try and work that one out. So from our equations that we studied last time, we have this. Now if we write out what information we've got 45 is equal to 0 times t plus a half times 10 times t squared. Okay, now what we need to try and do is get the t squared onto the other side. So let's have a look at how we set this out. Now let's go through and see if we can do some working out here. So we've got 45 is equal to, now 0 times t is equal to 0. So then we've got a plus half times 10 times t squared. Okay, now what I'm going to do is I'm going to move on to a new slide so we can take this calculation here and we can go on to the next section. Okay, so here is our section here. Now we can first of all get rid of the 0, okay, and we can cross that one out. Now the next thing we want to do is we want to get rid of this half. So what we're going to do is we're going to multiply both sides of the equation by 2, and that will get rid of the half, because if we multiply a half by 2 we end up with 1. So we've now got 45 times 2 is equal to 10 times t squared. Now remember the 0 has gone because 0 plus anything is going to be 0. Now the next stage is to divide both sides by 10 to get rid of this 10 times t squared. So now we have 45 times 2 divided by 10, which is equal to t squared. Now if we do 45 times 2, that's 90, divide that by 10, we end up with 9 equals t squared. If we do the square root of 9, we end up with 3, so it takes 3 seconds for the stone to hit the bottom of the top of the sea. Okay, so the next part is to try and work out what the stone's velocity was when it hits the sea. So what we're going to do is we'll have a look at our SUVAT again, and let's have a look at what information we know already. Okay, so we know the distance is 45. Now we know that we're looking at the velocity due to gravity, so the initial velocity is going to be 0. we're trying to work out the final velocity, and we know that the acceleration due to gravity is 10, and we also know that t is 3 from our previous problems. Now, the equation we're going to need for this is we're trying to work out our final velocity. So we've got the initial velocity, we've got the acceleration, and we've got the time. So if our initial velocity is 0, our acceleration is 10, times our time, which is 3, we've got 30 meters per second. So this is our vertical velocity. Okay, we're now going to try and work out the horizontal velocity. Now, the horizontal velocity is in the initial question. Okay, so we've got the horizontal velocity going this way is 3 meters per second. Now, the vertical velocity that we've just calculated is 30 meters per second. So if we have a look at our resultant velocity, which is this value down here, our VR, resultant velocity, is equal to V1 squared plus V2 squared, and we square root that. So we've got 3 squared plus 30 squared, and we square root that. So that gives us the square root of 909, which gives us our resultant velocity of 30.1 meters per second. Okay, so we have done quite a bit here of maths. It's quite tricky maths, and you need to make sure you can try and follow along with those. It's really worth making sure that you know what you're doing at each step, because as I say, it's multi-steps as we go through those equations, and it's making sure you know where the different numbers come from and where they fit into the reaction or into the calculation. Anyway, I hope you've enjoyed this. I do understand it has been a bit complicated, but I will see you next time. Bye bye for now.